Okie doke, let's now have a look at using tree diagrams to work out the probability of an event happening. So I'm going to do example 12 in your textbook. So this is page 329. So if you do want to follow this in the textbook, then I suggest you grab that. But it looks at two different bags of jelly beans. So I'll draw those bags. So here's bag A, and here is bag B. In these bags, there are different coloured jelly beans. Bag A has 4 red jelly beans. Bag B has 2 red jelly beans. Now in the book it talks about yellow jelly beans. I haven't got yellow set on here, so we're going to look at blue jelly beans. So bag A has 1 blue jelly bean, bag B has 3 blue jelly beans. So just to reinforce what we've done so far, there is a 1 in 5 chance of picking out a blue jelly bean from bag A. And if I reach in to get it and pick out a red jelly bean, there is a 4 in 5 chance of that happening. So we have for blue, we have a 1 in 5 chance happening here. And for red, we have the 4 in 5 chance. Bag B, to pick out a blue, we have a 3 in 5 chance. And for red, we have a 2 in 5 chance. So these are the probabilities of reaching into either of these bags and just pulling out a blue jelly bean or a red jelly bean. Now, what does this have to do with our tree diagrams? Well, what we can do is we can represent a situation with a tree diagram. Let's say that I select one of the bags. I toss a coin and that determines which bag I get. So I can either get bag A or I can get bag B. So this is our first event happening, bag A or bag B. Now because we use a coin to determine which bag, there is a 1 in 2 chance of getting either of these bags. Then what I do is whichever bag I get, I reach in and I pick out a random jelly bean. So now there are 2 different things that could happen in either of these bags. You could either pick out a red jelly bean or a blue jelly bean. But we've noticed before, when I set this up, there's a different chance of picking out a red jelly bean than there is a blue jelly bean. And that the probabilities or the chances are different for bag A and bag B. So let's look at bag A first. And let's look at the probability of getting a blue jelly bean. The way we can represent this on our tree diagram is I can draw another branch coming from A. This is getting our jelly bean. And for a blue one, there is a 1 in 5 chance of that happening because that's what we determined before over here. The other thing that could happen when I select bag A is I could get a red jelly bean. But the chances of that happening, as we determined earlier, are 4 in 5. So, just to recap, I flip a coin. I could get bag A. I then reach into bag A to pull out a jelly bean. I could either get a blue jelly bean or a red jelly bean. And there are different probabilities of these happening. So, for bag B, let's have a think. 2 things could happen. I could get a blue jelly bean And the chances of that happening, well, we determined are 3 out of 5. I could alternatively have picked out a red jelly bean randomly. Chances of that happening are 2 out of 5. So now what we have are our 4 different outcomes. This outcome up here, this one here, and this one here. This outcome here corresponds to picking bag A and then getting a blue jelly bean. This outcome here corresponds to picking bag A and then getting a red jelly bean. This outcome here corresponds to picking bag B and getting a blue jelly bean. And then we have bag B and a red jelly bean. But because these have different probabilities here for picking a blue jelly bean and a red jelly bean, and then they are different again depending on which bag you pick, the probability of any of these 4 outcomes is different. They're not all the same. But the way we work this out isn't too difficult. Let's start back here at the base of our tree, and let's look at this possible outcome here, where we've got bag A and a blue jelly bean. We follow the branches, and we look at the probability of each of these things happening. Well, we have 1 in 2 chance of getting bag A. So 1 in 2. Then we have a 1 in 5 chance of getting bag B, times 1 in 5. So if you remember back to our compound events, that when 2 events occur, the probability of both of those events occurring together, which in this case is picking bag A and getting a blue jelly bean, we times them together. So we have 1 in 2 chance of getting bag A times a 1 in 5 chance of getting a blue jelly bean, which then that equals 1 in 10. Next, let's look at the probability of getting a red jelly bean. Well, first of all, there's a 1 in 2 chance of getting bag A, that's still the same, but this time there's a 4 in 5 chance of getting a red jelly bean. So we times these together because there's 2 events happening, and we go 1 times 4 is 4, 2 times 5 is 10. There we are. So now, I'm not going to do this other component here. I'll leave that to you. The main thing to remember is, how do we construct these tree diagrams? How do we assign probabilities? And then how do we use these branches to work out the probability of some end result here?